I'm Anil Kumar, and now let us discuss rates of change. A ball of paper falls from the top of CN Tower. Its height h above the ground in meters after t seconds is given by h of t equals to 603 minus square root of t square plus 9, where t is greater than or equal to 0. Determine the average rate of change of the ball in the second second. Part B is determine the initial velocity of the ball. You can pause the video, answer this question, and then look into my suggestion. Now, when we say determine average rate of change of the ball in the second second, it's kind of confusing, right? So, first second is from 0 to 1, and second second is from 1 to 2. So that is kind of important to understand. So whenever we say second second, it means time 1 is 1 and t2 is 2 seconds. Do you understand? So that is the second second. So from 0 to 1, if t is greater than or equals to 0, from 0 to 1 it is the first second, and from 1 to 2 it is second second. So now I think it's very easy. You can always find the solution. So basically you have to find h of 2 minus h of 1 divided by 2 minus 1, correct? So that gives you the solution, correct? So that is the average rate of change in the second second. So you can do these calculations and figure out the answer. Anyway, we can also do it. So we can write, if I write t as 2 here, 4 plus 9, 13, well, it's a lot of calculations. So you do it yourself, divide by 2 minus 1 is just 1. So it is difference of h of 2 minus h of 1, correct? So that's not difficult. And of course, the units will be meters per second. So do the calculation, write down your answer. The second part is determine the initial velocity of the ball. We are actually doing calculus, and we are trying to review our skills which you have learned in rates of change in other subjects, especially advanced functions. So it is more related with that. Part 2 is determine initial velocity. Now, what do you mean by initial velocity? That means we are looking for instantaneous rate. Of change at t equals to 0. So that is what it means, right? So you need to find instantaneous rate of change at t equals to 0, right? How are you going to do this? Now, instantaneous rate of change of this function could be written as the slope of a tangent, right? So we can write slope of the tangent, where the limit, we can say take 2 points. One, of course, will be at t equals to 0. The other one very close to that. So we say h of, we'll write general expression first, and then we'll continue. H of t divided by t plus h minus t, right? So that is what the function is. In our case, since t is 0, so what we will have here is we'll put t equals to 0 and then write down the expression. So the expression will become limit h approaches 0, and h of t, I'm writing t equals to 0, right? So we say at 0 plus h, so we get what? We get, let me write one more line, 0 plus h minus h of 0 divided by t. Okay, so let's figure it out. So we have h0. So when I substitute h plus 0 here, I get what? So I get, within brackets, let me write down 603 minus 0 plus h whole square is square root of h square plus 9. Perfect. So that is my h of 0 plus h. Okay, minus h of 0, I'll write 0 here. So I get 603 minus square root of 9. Perfect. Divided by t. Now divide by, sorry, h. So divide by h. So that is our expression. Now let's simplify it further. So we have limit h approaches 0. Let's open this up. 603 minus 603 is indeed 0. So we are left with, here we have minus sign, and minus minus becomes plus for us. So square root of 9 is 3. So better we'll write 3 minus square root of h square plus 9 square root divided by by h. Correct. Now to solve this expression, we should rationalize. So we'll do it on the right side. So the slope or instantaneous rate of change will be limit of this function when h approaches 0, 3 minus square root of h square plus 9 divided by h. So we'll rationalize, that means we'll multiply by 3 plus square root of h square plus 9 divided by 3 plus square root of h square plus 9. So when you do that, what do you get? You get a square minus b square, that means 9 minus h square plus 9 divided by h times square root of h square plus 9. Now if you open the numerator, 9 minus 9 is 0, so you are left with limit h approaches 0 of h square divided by h times square root of h square plus 9. Now as you can see, one of them cancels out. Right? So one of them cancels out, and at this stage you can substitute h equals to 0. So when you substitute 0, you get 0 over square root of 0 plus 9, which is indeed 0. And therefore we get that the initial velocity of the ball should be 0, right? So that gives us the initial velocity. So the answer is that initial velocity is equals to 0 meters per second. So that is how you can solve it. I hope that helps. Thank you and all the best.